So we have our rule for adding and subtracting exponents. It's just combining like terms. We have our rule for multiplying powers. We add the exponents. And then when we have a power of a power, we multiply the exponent. So the only rule we don't have yet is for dividing exponents. So I want to do an example first, just like we did last time. So write down example 1, please. Okay. We have x to the 11th power divided by x to the 5th power. Okay, x to the 11th power. Let's actually write the whole thing out. X to the 11th power is x times x times x times x. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 x's, all on top being multiplied. All of that is over what? How many x's are in x to the 5th? 5. X, let's do x times x times x times x times x. 1, 2, 3, 4, 5. Okay, so we just expanded the whole thing out. Okay, really quickly. If I give you x divided by x, what is that as your answer? What's x divided by x? 1. Okay, so how many times can we reduce x? That turns into 1. That turns into 1. That turns into 1. That turns into 1. And this one turns into 1. So how many x's am I left over with? 6. So my answer is x to the 6th power.
I can do this.
Did anybody notice a shortcut here?
Mm-hmm.
Everett? Yeah, we subtracted the exponents. Okay? So that's our rule. So underneath example 1, let's write the rule for dividing powers. The rule for dividing powers, if I have a to the m over a to the n, my answer is a to the m minus n. So we subtract the bottom from the top. Okay? So it's the top exponent divided or subtracted from the bottom exponent. And we subtract those exponents. Make sure you write that rule. So let's look at example 2. This one is similar, but it's a little bit different. So we have y to the 20th power over y to the 30th power. Okay? Alright, so let's look at this. What was my rule for exponents when I'm dividing? Subtract. So this is the same as y to the 20 minus 30. Okay, so it's always top exponent minus the bottom exponent. Okay, it has to go in that order. So what's that going to give me? Y to the what? Good, negative 10. Now, I am not allowed ever in math to have negative exponents as my answer. So what do I have to do here? Ellie? Yeah, we have to take the reciprocal. This is y of 1, right? And y has a negative exponent. So we have to take that negative exponent and move it to the denominator. So what's my answer going to be? 1 over y to the 10th power. Does anybody see, I'm going to put example 1 and 2 up next to each other. What was the difference between examples 1 and 2? Think about it. Don't say anything out loud. Look at example 1 and look at example 2. Now turn to your neighbor and tell them what's different between the two. Giorgio, what was the difference between examples 1 and 2?
The example 1 wasn't a negative, and example 2 had a negative.
Okay, so in our answer, example 1 had a positive exponent and example 2 had a negative. Did anybody notice why that was? Anthony? Uh-huh. Great. That's exactly what I wanted you guys to notice. In example 1, the numerator, the exponent is bigger than the denominator. In example 2, in the numerator, the exponent is smaller. So, what conclusion can we draw from that? It's going to be negative if the top number is smaller, which means that our answer is going to show up on the bottom. So, wherever my bigger exponent is, that's where my answer is going to end up. Does that make sense?
Yeah.
Okay, let's write a little note there right underneath example 2. Wherever the bigger exponent is, that's where the answer goes. I can't think of a more sophisticated way to say that, so that's just what we're going to write. Okay, so wherever the bigger exponent is in the problem, that's where your answer goes in your answer. So in example 2, 30 is bigger, so we knew that all of our y's were going to end up on the bottom. And then we can just subtract like normal. Okay? Okay, so let's look at example 3. This time we're looking at two different bases. X squared, y to the 5th, over x to the 7th, y to the 2nd.
Oh, why did I write example 5?
Okay. So let's see if we can apply our shortcut here. Okay guys, so just like when we're multiplying, we can only look at bases that are the same. So we have to only look at the x's together, and then we can look at the y's together, okay? So draw your fraction out. Let's work on the x's first. Which has more x's, the numerator or the denominator? The denominator. So where's my answer going to end up?
On the bottom.
On the bottom. So it's going to be x to the 7 minus 2. Okay, so if we use that little trick, we can just subtract the bigger one minus the smaller one. Okay, we don't have to worry about the negative exponents anymore because we figured out the trick. Okay, what about my y's? Where's the more y's, in the numerator or the denominator? Numerator, so that's y to the 5 minus 2. So then what's my answer? Y to the 3rd over x to the 5th. And that's your answer. Okay? So if you use that trick, you don't have to worry about negative exponents ever. You just put your answer where the bigger one is, and then you can just subtract the biggest minus the smallest. Okay? Okay guys, so let's see. Let's look at the A's first. So I'm looking at the A's. I'm going to draw my fraction. Where are my A's going to end up? In the numerator or the denominator? Who's in 27? Nate, where are my A's going to end up? On the bottom, the denominator. And that's going to be A to the what, Nate?
32 minus 10.
Good. 32 minus 10. Okay. Let's look at B's. We have B to the 8th over B to the 10th. Where are those B's going to end up, Christy? On the bottom. So that's going to be B to the what? 10 minus 8. Thank you. I just want you guys to show your work, okay? Okay, so nothing is up in the numerator at all. So what can I put up there in the numerator, Samuel?
1.
A 1. Okay, so let's simplify our answer because this is definitely not a complete answer. That's going to give me 1 over a to the 22nd, b to the 2nd, and that's your answer. Can you raise your hand if you got that correct? Awesome. Great job, guys. Okay, so what happens, because I've had some people looking ahead already, in example 5, what happens if there are numbers involved? So we have 9x to the 15th over 18x to the 8th. Now, when I was grading your quiz A's from Friday, I know we've gone over this already, but it looks like we have to go over it again because I think every single person missed this one problem. Not this exact one, but it had something similar in it. So we are looking at the coefficients first. 9 over 18. Can that be reduced?
Yeah.
Yes, it can. What can it be reduced by?
3.
2 does not go into 9. What goes into both 9 and 18? 9. 9 goes into 9 once, and 9 goes into 18 2 times. So that reduces to 1 over 2. Okay, before I write anything else, let's look at the x's also, okay? So looking at my x's, is my answer going to end up in the numerator or the denominator?
Numerator.
The numerator. It's going to be x to the 15 minus 8. Since there's also a 1 in the numerator, but the x's are there, do I have to write the 1? No, we don't have to write it. Okay, so I'm not going to. And so then what's left in the denominator?
2.
The 2. Okay, so the 2 stays because we reduced it.
Oh, so we don't need the 1.
You don't need the 1 because it would be 1x to the whatever. You don't have to write
And then
it.
the x.
Right. I'll write it for right now, and then in the next step I'll reduce it. Okay, so that's going to give me 1x to the 15 minus 8 gives me just x to the 7th power all over 2. And that's your answer. So you're reducing the variables, but you also have to reduce the coefficients, okay? I think almost every single quiz from Friday, from the ones that I graded, everybody or almost everybody would have gotten the correct answer except you didn't reduce the coefficient, okay? So last one before we call it a day, I want you all to try example 6 on your own. When you are finished with example 6, put your pencil down so I know you're ready. Let's see. Let's reduce the numbers first. So 6 over 8. What do those reduce by? Who's in 16? What goes into both 6 and 8? 2. 2 goes into 6 how many times, Bobby? 3. And 2 goes into 8? 4 times. Okay, so I'm going to write my fraction. I know I have a 3 and a 4. Let's look at the y's also. Are my y's going to end up on top or on bottom? Who's in 32? Madison. Are my y's going to end up on top or on bottom? On bottom. So that's going to be y to the 12 minus 7, right? So what did you get as your answer? Who's in 23? Anthony, what'd you get? 3 over 4, y to the what? Perfect, y to the 5th power. Is that what you guys got?
Yeah.
Thumbs up if you agree?
Wow.
Excellent, that is our answer. Okay guys, so I want to do a quick recap, and I think it would be a good idea if you wrote this at the end of your notes. Okay, so we have now learned 4 different rules for exponents. Okay, so if I have, let's see, addition or subtraction. So if I'm taking exponents, let's say, let's write out rules of exponents. Okay, our first rule is combining like terms. We've been doing that since the first day of school. Okay, so first rule is combining like terms. And that means we are either adding or subtracting. Do the exponents change? What do we do with the exponents? Does anything happen? Exponents stay the same. So exponents, I'm going to abbreviate exponents to EXP, stay the same. Or, yeah, stay the same. Okay? So combining like terms, addition or subtraction, exponents stay the same. The next thing we learned was multiplying powers. Okay, so multiplying powers meant there was a dot in between or parentheses times parentheses, right? Something that looks like either that or that. What do we do with the exponents there? If I'm multiplying powers, what do I do with the exponents? Add them. So we add exponents. This little cheat sheet might come in handy on a quiz or something. Okay, we also learned powers of powers. And power of powers meant I have a parentheses raised to an exponent. I'm going to use the exponent 5, but it really doesn't matter what it is, right? And what do I do with the exponents there? Distribute or multiply. Same thing. Okay, let's actually write both. Distribute or multiply exponents. And then the one we just learned today, dividing at powers. And what do we do with those? If I'm dividing powers, we subtract exponents. Okay. So those are all of our rules of exponents. We've learned 4 of them. Coming up in the last couple of lessons, we're going to be having to maybe use multiple rules in one problem, which is why it's very important for you to be able to know the difference between each one. Okay?